Hello, Heritage Academy geometry students, and welcome to another adventurous edition of Geometry, Seeing, Doing, Understanding. This is lesson 3.6, Linear Pairs and Vertical Angles. And as always, this presentation is brought to you by me, Mrs. Elzagary, PowerPoint, and the Internet. So as we continue moving through chapter 3, we are continuing building on our knowledge of lines and angles. But before we go any further, let's establish those ultimate objectives and intermediate objectives. So chapter 3 has been all about lines and angles, and we know that because God created the earth, he also established beautiful lines and angles in all kinds of living and non-living things. I don't know about you, but I take lines and angles for granted in our everyday life. I don't really think that much about them, but they're pretty stinking important. And of course, we want to continue to study our lines and angles and learn what we can about them, because the more we learn about the world around us, the more we're really learning about our Creator, and he's kind of a big deal. So we also want to talk about intermediate objectives specific to lesson 6, and those are to define and identify linear pairs and vertical angles, and then we're going to explore some properties and theorems of linear pairs and vertical angles. So once again, this is lesson 3.6, linear pairs and vertical angles. You can find out more about this on pages 110 through 112 in that giant textbook that you bought that I really hope you're using. Check it out. We've got this aerial shot of railroad tracks cutting through a super forested area. For simplicity's sake, let's just pretend like these tracks are running in kind of a northeast-southwest pattern. Of course, a little closer to north and a little closer to south there, but not running directly north and south. Now, let's say that your job is to cut a road going directly east and west through this heavily forested area. And at some point, that road, you know, is going to intersect these railroad tracks. So maybe your road is going to cut right through here. Now, this is a great example of where lines and angles become really important in our everyday lives. So now let's just focus on the lines that we see. Let's put a couple of points up on those lines because we know that we need to have a couple of points to make these straight lines. And then let's go ahead and throw an extra point right there where those lines are intersecting. So check it out. The point in which the lines intersect, point P, right there, you can see it, it divides each of your lines into two rays. So check this out. At point P, now we can say that from P to A, that's a ray. From P to B, that's a ray. From P to C, that's a ray, and from P to D, that's a ray. So we can talk about more than just these lines now. We can also talk about rays. What else stands out here is something called opposite rays. So this is where we have rays which point in opposite directions. So our pairs of opposite rays in this picture include rays PA and PC, and rays PB and PD. Alrighty then, now that we've covered a little bit about opposite rays, let's rename these angles, because saying something like angle APB or angle BPC, that's just really annoying and it takes a lot of time. So I'm just going to call these angles 1 and 2. So what can we say about angles when we see them? Okay, so this is where we're going to get into an inquisitive mindset. We want to ask questions and we also want to identify what we see and know here. So let's consider angles 1 and 2, and let's start by just thinking through this. Are they acute? Are they obtuse? Well, we have one of each. Angle 1 being obtuse, angle 2 being acute. That's a good observation to make. Also, we can see pretty easily that they're both sharing that line AC, and that they both share the ray PB. Now remember, AC has been split up into those two opposite rays, and that's going to be really important. So remember that. Now, the next thing that we can think about is that they're right next to each other. Also, they're right next to each other and they sit on this straight line, which means they're going to be supplementary angles, or their sums are going to equal 180 degrees. So looking at angles 1 and 2 bring us to an important definition, which is called linear pair. Two angles are a linear pair if and only if they have a common side and their other sides are opposite rays. So that sounds kind of complicated. Let's just break this down a little bit. Their common side is that ray PB. You might be wondering, what are the opposite rays? Well, their opposite rays are actually along that same line, AC. But the rays that are opposite of one another, remember, are PA and PC. This is important. Linear pairs, such as angle 1 and angle 2, are always supplementary angles. So if you know the measurement of one, you can find the measurement of the other. That is a crucial piece of information as we move forward, and you might have already known that. Did you make a little bit of a connection here between linear pairs and supplementary angles? I hope you did, because I have a theorem for you. And that theorem states the angles in a linear pair are supplementary. So we're really just adding some vocabulary and some ideas here to some concepts with which we're already very familiar. All right, so we're back at our lines and angles that we were talking about before. Let's go ahead and finish this off with angles 3 and 4, and let's see what else we can ask about these angles, because we want to be inquisitive, get in that mindset. So let's consider all 4 angles and ask a few questions. Like, how many angles appear to be acute and obtuse? Okay, so I can pretty easily see that angles 1 and 3 are obtuse and angles 2 and 4 are acute. But there's more going on there, and we're going to get to that soon. What about how many linear pairs exist? We know that 1 and 2 are linear pairs. What about 2 and 3? Or 3 and 4? Or even angles 1 and 4? We'll go back and look up your definition for linear pairs and see what you think, and we'll discuss that more in class. Also, what can we say about the angles that are opposite of one another, like angle 1 and 3? They kind of seem like they're opposite, right? Or angles 2 and 4. They seem opposite, kind of like mirror images. Those are going to be really important, and that's where we're headed next. So let's talk again about angles 1 and 3 and angles 2 and 4. They seem kind of like opposites or mirror images, and I want you to keep that idea in mind, because we actually call these vertical angles. And while the definition is going to sound a little complex, the idea behind it really isn't so difficult. So 2 angles are vertical angles if and only if the sides of one angle are opposite rays to the sides of the other. Well, what that really means is that our vertical pairs here are angles 1 and 3 and angles 2 and 4. And this is because they have opposite rays from one another. It's important to think about vertical angles like opposite angles on opposite rays of a line that are always equal. So that's the really special relationship here, is that these angle measurements aren't just on opposite rays, but they're also equal, which brings me to my next point. So the definition for vertical angles might have been a little bit of a challenge, but the theorem actually is quite simple. Vertical angles are equal. So that is our second theorem that we will be exploring more in class. So here's one last set of lines and angles to consider. And I want you to pay attention to this, because this could show up on maybe a do now or even a test. And it's really important for you to get into that inquisitive mindset where you're looking at what you already know to be true and also start to ask some questions about it. So here's a couple of things that should jump out at you. There is a right angle in this image that is marked. There are also 2 straight lines right here. There is also this peculiar little ray, AK. And this ray is going to become important as we study this set of lines and angles. So if we want to number these angles 1, 2, 3, 4, and 5, are there any areas where you can see maybe we have a vertical angle or a linear pair? What about acute and obtuse angles? What are you seeing in terms of that? Do you see complementary or supplementary angles? These are all ideas I want you to consider and be prepared to talk about the next time we meet in class. But until then, get those Cornell notes nice and polished up, and you can be in your book reading pages 110 through 112 before the next time we meet.